Okay. Good day, everyone. Good day. My name is Nemeka. I'm a data scientist at Harmony Labs, and today we'll be discussing on MLOps with Kubernetes, right? Kubeflow, Kubernetes. And so let me share my screen. I hope I'm audible. I hope I'm audible as possible. I'm all right. Let me share my screen. All right, please, if you can see my screen. Okay. Check if you can see my screen. So today we'll be talking about MLOps with Kubeflow, and for be deploying machine learning models, deep learning, and deploying TensorFlow 7. Today we'll just be sticking with case just hope. All right, so let's get started. So I'm working with this repo today. It contains all the code I'll be using for this session and all the files I'll be configuring today. So after the session, it will be shared with everyone, the respective channels. So let's get started. Let me open my Visual Studio Code, and today we'll be working on deploying a deep learning model, right? I don't know if most of you know what deep learning models are. I think I didn't stop something. Okay, I stopped it. Okay, deep learning models are just like, let me say they are like using deep learning, TensorFlow, not scikit-learn, right? And the deep example of a deep learning model is most likely ChatGPT, right? And you'll be asking yourself, how is OpenAI able to serve lots of people? Like, you can make a request, I can make a request, and we can get responses, millions of users, right? This is where the deploying comes in place, right? Most likely AI have a lot of computers, a lot of GPU, a lot of software engineers, and people that know what they do when it comes to deploying models, right? So, but today we'll just be working with simple MNIST data sets, and this is the MNIST data set here. And let me just give us an overview of what this is, right? The model is going to be able to classify MNIST data sets, right? MNIST images. And like, so if you're sending an image, it's able to classify which number it is. So first, let me just show us what the MNIST data set is like. And data handwritten digit classification. Let me just say this data set. Okay. Um, so let me use the one from TensorFlow. Okay. Okay. So it's a set of images are watching the images here. Okay, yeah. So this is the data set here. So any data set is just mini handwritten. That just means database of handwritten digits, right? So what we're going to do is that, so we're going to train a machine learning model, a deep learning model, to be able to detect what number is sent to it, right? So if you send an image of a number, it can be able to know what number was written in that paper or in that image, right? So that's what we're doing today. We're going to be able to deploy it so you can make calls over uh data scientist, so the data scientist job, right? It's going to load the data, it's going to reshape it, it's going to normalize it, do some feature engineering, is going to um the it's going to the like what's it called? It's going to define the model, right? It's going to create the model, going to compile the model, and it's going to fit the model, right? Fits the model, and after fitting, it's going to evaluate to print out the accuracy. Then the most important part of it is saving the model, right? So when you save the model, you can now use that model, you can now deploy it like as an artifact, right? You're going to deploy the model. So when you save it, you can host it in a server, right? Something like that. And you'll be able to make requests to that model. So that's the key part. And I saved the model in image classifier folder, right? So this is the folder of the image. And this is something like the, as I will put it, this is just this is where the model, you can access the model from now, right? So the most important thing for you as a data engineer or the MLOps engineer or machine learning engineer is how can we deploy this model so end users can use it, right? So that's when we move into Docker, right? So in your material, you most likely have seen TensorFlow 7 there, and you might be wondering what it is, right? So let me go to your documentation and show you what they say TensorFlow 7 is, right? So TensorFlow 7 is a flexible, high-performance serving system for machine learning models designed for production environment. Production environment as in use case, normal use case like ChatGPT, like any other deep learning model that might be out there, right? That's production. That's when you offer it to end users, right? So TensorFlow 7 makes it easy to deploy new algorithms and experiments while keeping the same set architecture and APIs. TensorFlow 7 provides out-of-the-box integration with TensorFlow models. So TensorFlow is just like scikit-learn. I know you guys did the regression part of machine learning, right? So you know what scikit-learn is. So TensorFlow is just like scikit-learn, where you can call model of fits and stuff like that, and can be easily extended to other types of models and data, right? So for us to use TensorFlow 7, we're going to work with the Docker image. So I'm going to go to Docker Hub and search for TensorFlow 7. So we just need an image, just like we like the last class where we used was that MySQL? No, was that MongoDB? No, I forgot what we used the last class. Mongo Express and MongoDB. Yes, that's what we did. So just like that, we just need the Docker image, and there are different flavors, like how they said. There's the latest flavor, like that's just the minimal image. That's what we're going to use for today. There's latest with GPU, right? So GPU as in I know most of you know what GPUs are, like the NVIDIA on your PC, 2 gig, 4 gig, so that's the GPU, right? And the reason for GPUs is that it's faster than CPUs for machine learning tasks, right? So most likely OpenAI are using a lot and a lot of GPUs in their backend, right? A lot of GPUs. And so if you want to serve your models with GPU, you know that you most likely have faster inferencing. Faster inferencing that like the time to get the response is very fast. Like if you use CPU and get 2 seconds of inference time or latency, anyone you want to call it, latency inference time, your GPU most likely have 0.5 seconds, 1 millisecond, because GPU is faster. And there's now the Devel, most likely for development, and the Devel GPU. So we don't really need um to know about that. So, but if you want to use the GPU image, you most likely need NVIDIA Docker to run NVIDIA Docker to set that up, right? So let's just work with the latest, right? So I created a Docker file. I know we all know what Docker files are from now. We all know what Docker files are. So if you yeah, system is kind of slow today with number of tabs I have open. So let me see. So I know we all know what Docker will be, right? We know what Docker is and how to use Docker. So there are these commands you can use to create something called a Docker file, right? So this from TensorFlow 7 is going to tell the Docker file or the Docker that you want to download the image from TensorFlow 7, the name of images or the name of the repo is TensorFlow /7, right? So Docker is going to pull it from there. And now the most important part of it is this place where you copy your model saved into a particular folder in Docker image. So if you remember, a Docker image, right? So there's now a container, right? So after you've loaded the image is just like a step-by-step process to build the container. So in the container, you now have you now copy. It's almost like a system on its own. It's almost like a virtual environment, an environment on its own where you can have folder, can have IP address, can have a whole lot of port numbers and stuff. So what we're going to do is we're going to copy that image we trained into a folder in the Docker container, right? So the most important part of it is the /models. Then you can name the rest whatever you want, right? You can name it whatever you want. You can name it because you can have a whole lot of models, right, in your company, right? So you can have an image classifier, you can have a churn detection, fraud detection model. You can have a recommendation model, right? You can have a lot of models in your as a company, right? And so if you want to use TensorFlow 7 to serve, you can just copy the image, the saved model into the folder in the container, and you can put whatever number you want, right? Because of versioning. Right, so that's what we're going to do here. This is a command telling Docker to copy the particular folder from our local, right, this particular folder into the container, right, and save it here. So that's that. And so this environment variable model name is going to tell Docker that this is the name we're going to call the model. So we're going to call the model image classifier. So whoever wants to make requests to this model will have to use this name. Don't worry, when we are talking about the prediction part, we're going to I'm going to show you like what's happening, like why do we need to do this, right? So let me kind of recap here with a simple example. So right, so TensorFlow 7 can let you save images both in CPU and GPU, right? And there's also something key about it, right? This is a documentation, right? They offer you two different options of saving your model with gRPC and with REST API, right? So if you're familiar with backend stuff, like we all know what REST API is, right? If you've ever deployed an API like with Flask or Fast API or Django, right? You most likely know what a REST API is with the popular commands like put, um, post, get, I hope we all know what that is, right? By now, right? So that's REST API. Most of the web applications and JSON APIs use REST API format, right? And then the other one, gRPC, is a kind of more complicated format, right? In REST APIs, you use JSON, right? You use something like dictionaries, right? You use dictionaries to, JSONs to make requests, like the payload. How do you send information? Is through JSON, right? But in gRPC is something different. They call it protocol buffer, right? And I think the advantage of gRPC is the low latency. You see most of gRPC in anything that has to do with streaming, right? Something that needs to be live, that needs to be that quick, right? Go, come, and not so much of lag, right? Because gRPC is kind of faster with the encoding and without the encoding and decoding that has to occur in REST API. So, but the con of gRPC is the complication of the protocol buffer, right? It's a complicated protocol, right? So today we're just going to be using um, REST APIs. And the REST APIs are, like I said, a Docker image or a Docker container is almost like a computer of its own with ports and an IP address and volume and storage for storage and stuff like that. So we're going to be accessing port 8501 for the REST APIs, right? So if you see me writing a command with 8501, you know why, but there are two options, port 8500 and port 8501. 8500 for gRPC and 8501 for REST API. So you can, for on your own use case, find a way of implementing with gRPC, right? And that's almost like a project of its own, and you can just push that on GitHub and say you deployed a model with TensorFlow 7 using our gRPC. Right, okay. So that's that for that story. And so we are going to I've already built the model, right? I don't want to do that here because that's going to take some time to train the model and see if it's going to take some time. So I had the liberty of training the model and saving it already in that folder. And so what I'm going to do is in my command line, I'm going to try and build the image again. I built it before, but let me build it again. Let me clear up this. Why? So I'm going to run Docker build. All right. Um, the beautiful thing is that I've already built the image before, so it's going to just take a few seconds, right? I built the image, right? There's the file, there's the image, and there's the container. So I built the image with the Docker file, right? So I hope you guys understand that. So there's an image now in my local, and what I just need to do is VS Code. So what I just need to do is run the image and get a container running up and running. Right. So to do that, I just need to run this command docker run. All right. So when I run, let me explain the syntax of this command first. So docker run, it lets you run an image, right? And the command /it, what that does is that you want it to be run interactively. So you want to have access to the shell, the command line shell, right? You want it to still have access to the command line. Okay. So with the /rm means that when you close the shell, when you close the bash shell, you want the Docker container to be removed, right? So you don't want it to still be running in the background and taking memory, right? So that's why you want to put the --rm. And slash p means you're putting the mapping the ports, right? So you're mapping port 8501 of your local to port 8501 in the of the of the Docker image, right? Or Docker container. And so after running all of this, you're going to tell it what particular image you want to run. So you have a whole lot of images in your local, and you just want to select a particular image to run interactively. So if I run this now, okay, so it's ready to accept connections or accept requests to it. So what we now need to do is to just make a request to it, right? That's what we need to do. So to do that, okay, I'm going to call the predict is like as the end user, right? Since I'm just trying to show us something, right? I'm just going to run the predict for us here. So it's most likely like you when you send a particular like message to ChatGPT and it gives you a response. So in the back end, something is happening, right? There's most likely an endpoint you're making a request to, um and making a request to an endpoint and you're getting response. So what the whole user interface is doing is making you not to look at all this garbage, all this code in between, and just gives you a perfect user interface for you to just be streaming and typing and everything, right? So this is just like the programmatic way of doing it, right? So what I'm going to do is I'm going to load some sample images, right? I'm going to load some images. This is what I'm doing with the load data function. I'm loading an MNIST image, right? Sorry that I'm not plotting it for us here. I'm sorry. It's just like a quick intro, right? So by next class, we're going to do like a better rundown, right? So I'm going to reshape it like we did in the training side, right? So static learning is that when you train your model, the way you train it should be the way you make requests to it. So whatever you did in the training side, right, is the same thing you must do in the test side. So also, if you if you know a little bit of natural language processing, you know that in ChatGPT, there is something that is called tokenization. Right? The tokenization that occurs in the back. Right? So that particular text you type, like "I am a boy," is going to be converted to numbers because machine learning only works with numbers, right? No matter what, right? Even though you are let those who want to, right? And number is now going to be sent to the ChatGPT, which is going to do some kind of embedding and whatnot, right? Before it gives you numbers again. So those numbers again are now going to be decoded to text, and that's how you're able to see text outside. So it's almost the same thing. So you have images, you're going to convert those images to pixel values, right? To pixel values because numbers are your images are actually pixels, right? I don't know how I'm going to show this. Um, it's, I just hope people understand. But images are actually pixels, right? So those pixels are ranging from 0 to 255, right? I wish I can show us here. Um, so if I search image pixel value, example, I click Chrome. So, right. I don't know if you can see some of these things here. So what it's saying is that here, that this image, you see grayscale, but what it actually means the model is numbers, right? So that's what is happening in the background. Those images are turned to numbers, like those 09089 values are turned to numbers. So what I'm going to do is now I'm going to talk about the URL, right? So you okay, let me close that. All right, so you have an endpoint running now. You have an endpoint running in your PC, right? How can we send a request? Because in REST APIs with websites, you want to send a request, you need to have a web address or IP address, right? To send that request to. So it's almost the same case. How can we send in our requests to this TensorFlow image running in our PC? So there's also an example that was dropped by them. I just want to carry us to that place. So we see that when you're making a request to URL, is the IP address, the port number, the version, right? And the remember that we loaded the image into a particular folder, right, in local, and we're not going to call the predict. So what all of this is that this is how TensorFlow serving serves its model. This is how you're going to be able to query the model. This is how you're going to make a request to TensorFlow 7. You put in the IP address where the TensorFlow 7 is, right? In my own case, we're working in my local, so that's why it's localhost, right? Port 8501, like I said, is REST API we're using. If it was gRPC, report 8500. V1 means the version number of the model, right? Then this from here to the end, we're just talking about where we loaded the model to the link to the model. Remember, we loaded our model in what is it? In model slash image classifier slash one. So don't bother about the one. Remember, we called the name of the model image classifier. So what we're going to do now is we're just going to tell it models and the name of our model. Um, this colon is going to now tell it what action do you want to make, right? What action do you want to make with this API? So that predict means that you want to make a prediction. Let me show us with my own example, right? So this predict means you want to make a prediction with this API. So now I created a function, right? That's going to take our input, convert it to JSON, because it's JSON we're going to be using to make predictions. We're working with REST API. So what it's going to do is going to convert our test examples, X test, right, to JSON format. We're going to send a post request because we want to make a prediction. You send a post request. I'm just hoping that we have a background in Fast API and Flask, right? So you send a post request, you're going to get a response. That response, you're going to convert it back to JSON, and we're going to return that prediction. So I'm now calling the function. This is where in our own use case, the user interface is, right? So most likely the user interface where you can just drag and drop an image, right? I'm sorry that I'm not a UI designer or UX designer. I'm just a programmer like everyone here. So you most likely, or Streamlit, if you are familiar with Streamlit, you can just quickly simply interface with Streamlit. Then you call the make prediction. So I'm using 4 text examples, right? And for each of these examples, I'm going to call the predict. I'm now going to check the prediction that was made. Right? I'm going to print it out for us. I hope like we're not lost what I'm saying here. I hope it's as simple as that. Like as I claim to say it is. So oh, Chrome, Chrome. All right, so I'm going to the prediction now. Right, so to make the prediction, I'm going to use Python predict.py, right? So I created, remember, this is a Python script, right? And to make the prediction to that endpoint that is running here, I'm going to call Python predict.py. So Python predict.py, and it's now going to run that whole script for me, and it's going to get out the output. And this whole one is from TensorFlow. So we're going to get the output soon. Okay, so we see that the inference time was slow because I'm using the CPU, right? If it was not like a GPU, it's like faster. But we see that we made the true value, like this is the image, this is the value in the image 7. And the model was able to predict that that image was 7. and we sent another image of 2, and it's able to predict the value for 2. So let me show us where it is in the script. Okay, so where is it? Okay. So remember, I was iterating through all of the predictions, right? For I/slash trading and the next quick predictions. I'm hoping we are all Python by right? So I'm going to iterate through all of the responses, right? That we get. I'm going to get the actual value that was sent, like the white test, and the predicted value. That means what was returned in the predictions. And that's why I was able to get the model to predict 77221100. So we can see that the model we built and we deployed. So hope I'll be able to cover the seven questions, please. Uh, Drop them. I know this is somehow complicated material. That's why I just want to cover this short part. Um, I will share this repository with you. You can um, create a fork of the repository and play with it on your end, right? If you have any questions, you can always ask me when you can. So since there are no more questions, I guess this is the end of the session. All right. Have a nice day. See there are no questions. All right. Hello, what's that?
No, I was thanking you for the session. Though
All right.
this is really new to me and sort of
Yeah.
complex.
Okay. Yeah, I know that it's very, very complicated, like for the first time. So the best thing you can do is to just get the repo or look at the material because it was also showing the material, but it was showing in a complicated way. I just brought it out simply to show you that it's something you can do on your PC, right? And um, you can always check out the documentation too, right? So what I did, I can drop the link to to this this particular repo here for you, right? You can just use the text example that they used and follow it up to the end instead of training the model on your end. I think the model was the complicated part, right? So I've sent a particular repo for you. So I think the best thing is to try out this example, this simple example, right? That's the only way. Try out a simple example, look through the documentation, see everything that's done. And so before the next session, most likely on Monday, I'll go into more complex stuff that might just build on top of this, right? So thank you.
Thank you
Have
very
a good one.
much.
Hello,
Okay, I'm not share my screen again.
hello.
All right. Hello? Yeah, I can hear you.
Yeah, I'm sorry for the late response, but I was wondering, I don't know, I'm having a kind of issue. I don't know if it's the right place to ask. In setting up my Kubeflow, I've been trying to follow the procedure in the lecture notes. So when I I'm able to download the microkits. So under the dependents, in the microkit, the Kubeflow is not mentioned. So when I try to add it, it tells me it's not able to do this command. So I don't know if there is any, I'm using Mac OS. I don't know if that's the reason why. Yeah.
So you say you download microkits, but the kubectl is not there.
No, the Kubeflow, Kubeflow.
Oh, it can't be there. You have to install Kubeflow.
Okay,
Yeah,
you
they are, steps there.
You say?
There are steps there on how to install it. I said there are
So I
steps
have
there
to
on how to
install the
install it.
Kubeflow separately, right?
Yes, yes, you have
Okay,
to.
okay, thank you. That's what I wanted to know.
All right. All right. Okay. All right, thank you.
Thank you very much. Till next time. Thank you for the
Thank you.
session.